Okay, so we are now ready to define conservative and non-conservative forces. The concept is going to be very useful for us as we'll realize that for forces that are conservative, we are able to think of the work done by those forces as storing energy in some form, which we call the potential energy. We've already looked at energy of motion, which is kinetic energy. Now it's time to look at energy of orientation, of position of an object, and that's what will come from using these things. So let's begin by defining what a conservative force is. So if the work done by a force is independent of the path, then that force is conservative. Now, the word conserved has a very specific meaning in physics. It means simply that it remains fixed, it does not change over time. And we'll use that. We'll use the concept of something being conserved or the conservative forces, or we'll derive something called the conservation of mechanical energy, and we'll use this idea there. Okay, so if the work done by a force is independent of the path, then the force is conservative. On the other hand, if the work done is dependent on the path, then the force is non-conservative. Non-conservative. Now this is very important, as we'll see, and we're going to try to figure out what makes we'll apply this concept, the definition, to see whether some of the forces that we've come across, which is gravity or friction, whether they are conservative or not. Okay, so once again, if the work done by a force is independent of the path, then that force is conservative. If the work done is dependent on the path, then the force is non-conservative. Okay, so in the next video, we'll check whether gravity is a conservative force or not.